Hey guys, it's Corey again, and today we're going to look at another presentation from Imagine AI. How Sheng, the founder of ChatSimple, is presenting his kind of the history, some history of chatbots basically. But one of the interesting questions posed in this, and that's what we're going to talk about today, is can a computer pass the Turing test in 2024? Can it pass the Turing test? So Turing test is basically whether or not a human on one side can tell if they're speaking to a human or to a machine on the other side. So let's check this out and just see what his definitions are and how he kind of shows some of the different history.
Hello everyone, my name is Hao. I'm the founder of ChatSimple. Today I'm going to talk about the past, present, and future of virtual agents. Back in 1950s, Alan Turing was a teenager, and he was pondering the question whether a machine can possess the human intelligence. For this, he defined a test where you put an interrogator into talking to human beings, talking to two people. One is human being, one is the machine. Can he or she differentiate them? This later on known as the imitation game. So in 1966, Joseph was very curious about Alan Turing's questions. So he started building ELIZA, which is the first ever chatbot. ELIZA uses keyword-based matching, and it matches your whatever user type with the keyword database they have, and the response was a scripted response. The goal of ELIZA was to be a psychotherapist. Fast forward into the next couple of decades, people were competing to see.
So basically, the very first chatbot was keyword-based, and then it had scripted responses, and the goal was to be a psychotherapist, I guess. And that seems like a big goal, but anyhow, keyword response, and then keyword matching and scripted response.
They can solve the Turing test. There comes the Alice, which is a universal language process chatbot. Alice uses heuristic-based matching to match whatever users say and their database. The response is based on something called XML schema, which later on known as artificial intelligence markup language.
So XML was extensible markup language, I believe, and then AIML is artificial intelligence markup language. Must have been based on that. I remember back in many years ago, Microsoft came up and said, hey, the new programming language of the new world is XML. And I don't know that it ever really came to fruition, but XML was one of those markup languages that's very low density. The parameters around each one of the, every data item is wrapped with the name of the data item, basically starting it and ending it with a data item name and then item name / all in brackets. Anyhow, pretty low density data in there. A lot of it was just the formatting for these data structures.
It uses that to specify conversation rules. So fast forward to 2016, when I started my first company, selling to insurance company conversation solutions. It was a chatbot. I was searching online, what is the most popular way to build a chatbot? At the time, it was Dialogflow. It powers anyone to build a voice or chat interface. At the time, it was powering over 90% of the Google Assist app and Alexa apps. So it uses something called intent matching. What intent matching does is it uses something called NLP, natural language processing. It matches whatever you say to an intent that you predefined. Oftentimes, you guys went on a website, you talk to a bot, it responds, sorry, I don't understand what you mean. That means it failed to match whatever you input to an intent that they previously matched. So we built the chatbot to automate first notice of loss claims. That was a success. So 2 years later, I decided to join the Dialogflow team to build even better tooling for people who want to build conversational AI applications. This is what we come up with. This is a V2 Dialogflow, which we allow the user to build even bigger conversation flow, like this one. It's called a state machine, where you define each state by giving them the rules how they transfer from one state to another state. This can go to very complicated extent. On one project, we were building a state machine with thousands of possible states. That was really hard to manage. However, although we are able to build these big systems that's so complicated and highly integrated into different systems, the conversation experience has never been good. So far, we have seen keyword matching, heuristic matching, and to the intent matching, and conversation rules from a simple dictionary to something like XML-based to a state machine like that. But remember 5 years ago? Whoever talked to a chatbot not only feels like the chatbot is dumb, they feel themselves is dumb. Why are they talking to a chatbot? But things are about to change. In 2018, OpenAI first time released a GPT called GPT-1 It has 120 million parameters. What it does is a supervised learning. Supervised learning meaning we have human labeler to label each one of the conversation and feed that data into a large language model.
So supervised learning means you've got humans in there that are actually teaching it, which is good. And GPT-1, part of a large language model, that's kind of the future, and that's what all of these new AI tools are based on, is large language models, different learning mechanisms, and many, many more parameters these days.
It only works on specific tasks because these are the tasks it has been trained for. 2 years later, OpenAI released GPT-3. It has 175 billion parameters. What it can do is called self-supervised learning, where it takes all the internet text and data and try to use the previous context to predict the next keywords. We also have in-context learning, which later on known as few-shot learning, or what we put as in the prompt. So GPT-3 is the first one you get a chance to prompt how the AI would respond. On top of that, 2 years later, in 2022, we have ChatGPT. ChatGPT uses a technique called reinforcement learning with a human in the loop. So basically, what they do is they take the GPT-3 response, and they have it to respond to the same question 5 different times. And we have a human labeler based on the judgment of them, and then they rank the answer from 1 to 5. So we feed that data back to the large language model to train it, so it can align with the human value and the society value. With large language model, we can finally say no to keywords matching and conversation rules. This brings us to present days. What LLM actually unlocked is a few.
So I'll stop there. But what you're seeing is the chatbots have gotten more and more sophisticated based on the AI, the underlying AI, or various technologies under the hood. The big question is, is there a computer out there that can pass the Turing test? And I might argue that the technology that we've got with Air.ai could actually pass the Turing test if the person on the other side doesn't know that they're talking to a computer. So very interesting. And I know that I've got a lot of recorded calls of conversations where the person on the other side talking to Air didn't know. So do we actually have computers now that are passing the Turing test? Do we actually have AI built sufficiently large enough that it passes the Turing test? And I'll do another video and we'll look at the rest of this, but that's a question for today.